Algebra 2 students. Today we're going to look at multiplying and dividing rational expressions. Excuse me. Again, this goes back to your old fraction rules and your basic fraction rules, and they're the same with rational expressions. Please don't panic. This is easier and shorter than the add and subtract. So let's talk about multiply and divide. You had a notes page from the previous lesson called Just Like Fractions, Add and Subtract. This one is Just Like Fractions, Multiply and Divide. So, sorry, that paper rattling is probably loud. All right, let's look at these. You can write these down, like take notes on your own paper. These are for your purposes. You don't have to turn these in, okay? So, number 1 says 3/4 times 5/7. Okay? When we're multiplying, now they used an X for the multiply. I really wish they wouldn't do that, but it's okay. We can deal with it. The X in the middle there is a multiply. It's not a variable. 3/4 times 5/7. So we're going to multiply across and get 3 times 5 is 15. 4 times 7 is 28. Okay. What were our steps? We multiplied across. Top times top, bottom times bottom. If you look in the far right column, it says operations with rational expressions. Now, this example follows the same steps as the one we just did. We're going to multiply straight across. So on the top, we have 2x. And on the bottom, we have x minus 4 times x plus 1. And if you FOIL that out or distribute it, you get x squared. You have 1x minus 4x, so that's minus 3x. And then negative 4 times 1 is minus 4. Same process, multiply the top, multiply the bottom. You're just multiplying straight across. Okay? All right, let's move on to number 2. I'm going to take this off there so it doesn't get quite as cluttered. Okay, sorry about that. A little allergies going on here. Number 2 says 2 times 4 over 9. Now remember, when you see a whole number, really it is a fraction with the whole number over 1. 2 over 1 times 4 over 9. 2 times 4 is 8. 1 times 9 is 9. Easy peasy. Multiply across. Whole number over 1. Multiply across. Then we have 2 examples of rational expressions that follow the same pattern or same process as that example. Put the 3 over 1. Multiply the top. 3 times 8 is 24. On the bottom, 1 times x plus 6. Now, some of you would be tempted to simplify that 24 over 6, but remember what we talked about yesterday, that you can't do that because that 6 is added. So that x and 6 are like tied together. You can't reduce one of them unless you reduce both of them. Okay? In the next example, you have x plus 1. That's like a whole number. We put that over 1. Multiply on the top, 8 times x plus 1. On the bottom, 1 times x plus 6. You could even distribute that out on the top and make it 8x plus 8 over x plus 6. Again, we can't reduce anything with the 8s and the 6s because they're added together. So you can't do anything unless you can reduce all those terms. We're done. Okay, let's keep going. Number 3. 4 times 1 over 9 times 4. There are 2 ways you can work this one. You can multiply across like we've been doing and get 4 over 36 and then reduce that to 1 over 9. Or you can cancel the 4s out first and just get that 1 over 9. Let me go back here and show you that. Okay. If I see that I've got a 4 on the top and a 4 on the bottom, they're the same, exactly the same, 1 on the top and 1 on the bottom. I can cancel those out You have 1 on the top and 9 on the bottom. If you don't notice that and you just multiply it, you can still reduce it. You'll still get the same answer. Cancel, then multiply. Over on the right, we have examples of same thing. Now, remember that a plus or minus ties these two terms together. So an x plus 3 is considered as one factor. X plus 3 is one factor. X minus 1 is one factor. A plus or a minus sign ties those terms together where you can't separate them. But we do have an x plus 3 on the top and an x plus 3 on the bottom. Anytime you have the same factor, top and bottom, if you are multiplying and dividing, you can cancel those out. Cannot do that with add and subtract that we just finished. But you can do that with multiplying and dividing if you have the same factor in the numerator and the denominator. Doesn't matter if it's on the same side, left or right. As long as it's one in the numerator, one in the denominator, you can cancel out. What's left on the top? 2x. On the bottom, x minus 1. Boom, we're done. Can we cancel the x's? No, because x minus 1 is tied together with the minus sign. Okay, we good? Here we go. I keep asking you if you're good. It's a video. You can stop it if you need to, huh? Okay, here we go with 4 over 15. Make that bigger. Times 5 over 6. 4 over 15 times 5 over 6. Now, you can multiply first, or you can simplify first. If I multiply first, 4 times 5 is 20. 15 times 6 is 80. That reduces to, did I not multiply right? Sorry, 6 times 15 is 90. Don't tell anybody I teach math, okay? You can't multiply in my head. Actually can, I was just in a hurry. And 20 over 90 reduces to 2/9. Now, with these smaller numbers, it really doesn't matter whether you multiply first or simplify first. Watch what happens if you simplify first. The 5 and the 15 both divide by 5. The 4 and the 6 both divide by 2. 2 times 1 is 2. 3 times 3 is 9. It really does not matter with these, whether you multiply first or simplify first. When you get to the rational part, it's going to matter, okay? So simplify, then multiply, or multiply, then simplify. With that one, it doesn't matter. With these, it matters, okay? Before you know what you can simplify, you need to factor. Right? You're going to factor first. So we have, did I skip that other one? I think I did. No, I didn't. We did the x plus 3 and the x plus 3 and canceled those out. Okay. Losing my mind. It's time for summer. All right, here we go. Before we know here what we can cancel out or simplify, we have to factor. In the left fraction, what multiplies to 20 and adds to 9 would be 5 and 4. On the right side, that fraction, the greatest common factor there is 2. Because we've changed that one to 2 times x minus 3. And we've changed the left one to x plus 5 to x plus 4. Now, we're looking for any factors that are the same on the top and the bottom that we can cancel. There's an x minus 3. There's an x plus 5. So there's not anything left on the top. So that stays a 1. And on the bottom, you have 2 times x plus 4. Now, if you have a choice, you're writing these down for me, I am fine with you leaving it just like this. If you're working multiple choice, you may see it like that with the factored form, or you may see it distributed out to make 2x plus 8. Okay, that's multiplying. When you're multiplying with rational expressions, you're going to factor first, cancel out any factors that are the same on the top and the bottom. And then you're going to multiply top times top and multiply bottom times bottom. Now, in this one, you could multiply first and then simplify, but think about if you multiplied all that stuff together before you canceled anything out. It's going to be ugly, and to try to simplify it at the end is just going to be next to impossible. Factor first, cancel out what you can. Okay? All right, here we go to divide. Now, we learned some rules for dividing fractions, and we practiced this with our TSI review. You learned it as keep, change, flip. The math terminology for dividing fractions is multiply by the reciprocal. Okay, multiply by the reciprocal. So 2/3 divided by 1/8. We're going to take 2/3 and we're going to multiply it by the reciprocal of 1/8 is 8/1. There's nothing there that simplifies. That's going to be 16/3. Okay. Multiply by the reciprocal. That's our rule for dividing fractions, multiply by the reciprocal. Same rule applies when we're multiplying rational expressions. 2x plus 4 over x plus 3 divided by 5 over x minus 2. Now, I would factor this first as 2x, greatest common factor for 2x plus 4. Now, the first fraction doesn't change. It stays as 2 times x plus 2 divided by x plus 3. Multiply by the reciprocal. Now, and actually that one really didn't matter if we factored it because nothing's going to cancel out on the bottom or the top. On the bottom, when we multiply 5 times x plus 3, we get 5x plus 15. Multiply all that stuff on the bottom. This is x squared. This x plus 2, x minus 2 is x squared minus 4. Multiply that by 2, and you get 2x squared minus 8. Need a new stylus, can you tell? Multiply by the reciprocal. Okay, you want to factor first, cancel out anything. Well, you want to factor, then you want to flip, then you want to cancel. You don't cancel anything out until you flip it, okay? Because what's on the bottom goes to the top. What's on the top goes to the bottom. All right. One more example. 3/2 divided by 1/8. The rule for dividing fractions is to multiply by the reciprocal. So I'm going to take 3/2 and I'm going to multiply it by the reciprocal of 1/8, which is 8/1. Now, do you notice this 2 and this 8 both divide by 2? Which makes 12/1, which is just 12. Again, this one is fine. It's not going to cause any difficulty at all if you multiply first and then simplify. Again, you still have to multiply by the reciprocal. So you're flipping the 1/8. When you multiply that, if you multiply it before you simplify 3 times, if you had 3/2 times 8/1, 3 times 8 is 24. 24 divided by 2 is 12. Same thing. With the plain fractions, with the simple fractions, with the numbers, it really doesn't matter. You multiply first or simplify first. When you get to the rationals, it matters. Okay. So we still did multiply by the reciprocal, didn't we? Okay. Move this over. Now, we've got a flip here and a factor. We need to factor that bottom of that fraction, and we need to flip it. You can factor first or you can flip first. It does not matter. This x squared plus what multiplies to 3? I kind of jammed two sentences together. X squared plus 4x plus 3. If I factor that, what multiplies to 3 and adds to 4 would be x plus 3 and x plus 1. Some of you will be able to factor and flip in the same step. because you're talented like that. So we have 4 over x plus 3 times, up here we have x plus 3 times x plus 1. Remember, because we're multiplying by the reciprocal. On the bottom we got 4. What happens here to x plus 3? X plus 3's cancel. Can the 4's cancel? Oh, that's not just Mr. Dale, silly goose. 4 over x plus 3 times, that's not 4 on the bottom, that's x minus 7. What are you trying to do? Confuse these students? Okay, now, what do we have left? On the top, 4 times x, multiply this 4 times this x plus 1. On the bottom, x minus 7. Okay. So multiplying and dividing to me is much easier than adding and subtracting because you don't have to find the common denominator. It's not as long. You're going to, when you're multiplying, you're going to factor. You're going to cancel out anything that factors the same on the top and the bottom, and then you're going to multiply. With dividing, you're going to multiply by the reciprocal, so you're going to flip the second fraction and then follow your multiplication rules. At the bottom of this page, it says, when can you simplify a fraction or a rational? Did you do any canceling out when you were doing addition and subtraction? No. You can simplify a fraction and or a rational algebraic expression when you're multiplying or dividing. And actually, when you divide, you're multiplying by the reciprocal. Multiplication. I can't spell it and talk at the same time. Okay. With multiplication, when there are common factors, get real fancy here. Numerator, which is the top, and the denominator, which is the bottom. Have common factors. Well, that's it. Okay, you have a Savas Realize assignment, so use these notes to help you. Have a wonderful day.